So for right now, I'm going to get out of this and go and show the demo. So let me shrink this down and bring up my window. So we're looking at a blank window here. I'm going to go in to steering and load this data set. So I just pull that right into the window, and then after a minute of loading, we will be ready to go here. So we've got this window set. We have everything that we've been dealing with already. It does not already contain the solutions. So that's something that you have to make sure that if you're going to work with those, you know where they're located and you can bring them in yourself as you need them. In the past, we loaded them automatically, but there were so many data sets and we had so much data, and this was before, you know, computers had as much memory as they do now or processing power, and it just really bogged things down. So we chose to not bring them in by default and let the user bring in these data sets as they need to. So just to go over a couple of the things, I'm going to show how to do the annotations. So we will come down to the annotations module. We'll enable that. We have our options here. I will choose to do a north arrow and just mark out a box where I want to put it. And as soon as I let up, I have to go find that now. So let me go find where this is. So it's under support files, north arrows, and there are my options. So I'll choose this one and click OK, and it appears down here. And so right now, if I click again and wanted to modify it, it actually wants to create another north arrow. We need to make sure that we're selecting that tool and then click on it, and then we can move it to wherever we want to view it. We can resize this a little bit. And then the good thing about this particular north arrow, as I mentioned, as you change your oblique angle view, it actually changes its direction as well and points to actual north so that you can be representing the right areas. So you notice it's kind of covered up there, and so you might want to go back in and select this and give it a certain color behind it. We can choose white, and hopefully this works. And so again, I'll go back in, and of course it doesn't work. So anyway, that's something I'll mark down that we need to get working again. And as I mentioned, it moves along with your rotation here. So what we'll do is go in and we will actually create a scale bar now. And so what I'll do is choose the scale bar, move down here and give it a location where I might want to look at that. It brings up some properties for that, so I can change what units I'm looking at here. So they're meters. We can fill with a background color, so let me just choose white here, just in case, and we'll see what happens with it. We can specify, you know, where this is anchored to, and I've not really messed with this a whole lot, but there's some options there. There's some offsets and sizes. So we click OK, and it didn't put it where I wanted it to. It's actually up here at the top. So let's go back and let's choose this. It is not working. Okay, so I don't exactly know how to move this at this point. A couple of little bugs here that we're finding that we need to get worked out. But you should be able to just put it down here, define your area, click OK, and then it shows up. So it worked that time. I'm not sure what happened before. So we can choose this, we can resize it a little bit, change the size, and then, as I mentioned before, as we zoom in, it actually updates with every zoom level to let us know what the appropriate distance is. So that's one of the features there. I mentioned in the preview as far as adding images, so you can add an image and do the same thing, choose to put, this would be a logo. I'm not sure if there's any images here. I didn't really set this up, but basically you could put any logo for your company, for your district, the core castle if you wanted to, at a certain location in your grid on your display here. So that's what that button does, and the others are pretty self-explanatory. You know, if you wanted to give a certain text at a certain location, you would be able to do that. Various operations here for manipulating the size of the text and the color. And then again, if you needed to move this around, you can do that by selecting it and then moving it. Can't really resize this because it's text, so if you wanted to change the size, then you would go into the font and change the size here, and then it should be reflected in the attribute. Okay, so let's load in some solutions here and start working with those. So I will pull in my look to find my solutions, and I've got them all located here. So right now I'm just going to pull in and work with morphology change, and I think I can pull in the vectors and the water surface elevation and bring those in. You can see them coming in here. One of the things, so if you remember in the model control when we were doing that the other day, I'll just come in here real quick and show the output, and I have different lists. And so some of the options here for morphology is to turn on morphology change. So if you didn't turn this box on, you would not have this data set over here, and I'll show you a way to calculate that through the data calculator. Similarly, if you did not check the box for current magnitude, you wouldn't have that over here, and I'll go through and show you real quick how to generate this current magnitude with another tool. So for current magnitude, what we would really need to do is to take the components of the velocity. So a vector data set has a u and v component that it's showing to give you the size and the angle of the direction. And so what we can do is to choose the current velocity data set and come under Data Set Toolbox and choose to convert that vector data set to scalars. And so we would choose that data set, and in this case we want magnitude. We don't really care about having a separate direction, so we can turn that off. But if you wanted to have the individual scalar values for your x and y components of velocity, you could do that as well. But in this case, we would just do current magnitude. We can give it a name of the prefix that it will add on there. I'm just going to keep it a little bit different from what we already have, just so you can see what happens. Then you would click Compute. It would take a few minutes, and so down here in the lower left-hand corner, you see a percentage of completion. So that'll be done in just a minute. And then we'll have another current magnitude data set. I was just showing you a way to calculate that if you did forget to turn that off. Or turn that on. Okay, so it's done. We can hit done right here, and we have another data set that has the current magnitude. They're pretty much identical as far as the values here, but this is just showing you how to create this if you didn't turn on that option. So let's remove that, and then I'll show how to get your morphology change from your depth data set if you did not already do that, if you didn't turn on that option. So similarly, we would do that through the data calculator. So the data set toolbox, we'll go in and do, we're assuming we don't have our morphology change here. So we want to go in and get our depth. So go to the calculator here, get the depth, and we'll use all of the time steps. And you can do this different ways depending on what the change is you want to do. Some people use the initial bathymetry minus the final depth, and some people do final depth minus the initial, and it just gives you a different sign on the values that come out of that. So what I normally do, so my coworkers do the different thing, that I'll actually take the final depth and then subtract the initial depth. And to get the initial depth, you can just uncheck this box and use the 0 time step. And then that will give us the final solution minus that initial condition there. So let's just do, I'll give it a different name. I can spell right. We compute that, so it's, again, it's going out to the data set. It's performing these operations, and then it will come back and give us an updated list of the data sets available. So now we show another data set here called morph change. We'll click done, and then here we are, and we're looking at that morphology change. It doesn't look that great because of our range here, but I'll show in just a minute how we can look at that in a little bit different, with different contours and things. So anyway, that's one way of calculating the morphology change. And so the one that comes directly out of SMS, that you can see because of the difference in colors, that it's done the opposite way from what I just chose. So we'll just work now with the one that came from CMS. I'll switch over to that morphology change, and then just show you how to modify your contours. So you can come in here, display options. For the quad tree, we have contours turned on. Right now, I'm going to uncheck the box of vectors, and then go into the contour tab. And so by default, or right now, we have our colors that look like this. We have, it was set up to have 21 contour intervals. We can change this number to whatever we want, and it will update the range showing here. And it shows us what the range is in this data set. So we can actually change that and say, okay, I only want to look at a -5, and this is morphology change here, so I want to make a symmetric range. So I'll go from -5 to 5. I'll make this a odd number of contour intervals, and then I'll go into the color ramp and actually change to the palette method, go into user defined, create a new palette, and choose the magnitude difference data set for our palette. Click OK, and OK again. You see it updates the range here. We have a white for 0 change, and then the variations on either end. Now we can come back and click OK, and we should see this represented in the screen. So I'll go back in real quick, and I'll turn off the linear contours, and we'll be able to see this a little bit cleaner. I'll zoom into the inlet, and you notice we have deeper blues where we have some scour and erosion, and then yellows and warmer colors where we're actually moving sediment and accreting from what the initial condition was. And so this is a little bit how you do this. So for current magnitude, I mentioned earlier, so right now we're just using this global display options because the dataset specific is not currently working in this version. But we can go into the display options and now we'll change the vectors again. So for looking at current velocities and speeds, we might want to change this and instead of using that user-defined, we'll go back to the hue ramp, but we'll change the colors by hitting this reverse key to go blue as our minimum and red as our maximum. Change the range if we want, and so I'll put that there. You see the full magnitude range goes up to about 1.5. And then when we come out, we see those reflected here. Similarly for depth, we can change those. So the other thing that I mentioned earlier is going to be the vectors. I'll turn that on, and then we can look at what the default is, or what was the default when we saved this project. And you see that we have only vectors being shown where there's significant flows, so right here in the channel and out into the object, and everywhere where there's negligible current velocities and speeds, we don't get any vectors whatsoever. So we can modify this and change it a little bit. So let's go into the display options, go to vectors, and we can change this. Instead of being scale length to magnitude, we can say, okay, I want to see a certain size minimum regardless of the value, and then a maximum, say 40 pixels long. So we'll go out and we'll look and see what this looks like, and as we zoom in and out, it redistributes those arrows. And so we can just keep playing with those until we get how we want this to appear. So it just is up to your preferences. You can change the color for the actual arrows if you want. Some people want to see these as white, things like that. And there's a lot of different options here. So that's how you manipulate your vectors. So moving on, I'm going to go in, and we'll turn these vectors off again, and show you a little bit about the plot wizard and those two ways of getting values for your plots. So let's just zoom in real quick, and I will go over to our map module. I'll create a new coverage. That is the observation coverage. It shows up down here, and then I can create a point, and I'll just choose a point in the inlet. And all I really need to do now is, that point is already there. I don't need to select it or anything. I can just go under Display, Plot Wizard, and I believe I can also come down here to this option right here for Plot Wizard as well. They do the same thing. We'll choose Time Series. And then we can choose what data sets we're going to be looking at. So I'll just do a couple of these one at a time just to show you what it looks like. So again, I'll just choose water elevation for right now and click Finish. It goes out there and it pulls the values from the solution for that exact point or the nearest point. And then in a second, it will update this plot. So there's 720 times, so it may take a minute or so to gather all of that information. I didn't think it took this long, but and my plot window is gone. Where is it? I'll try this one more time. Go into Plot Wizard, Time Series. Oh, there it is. I don't know where it was a second ago. Anyway, here's the window that was created by the plot wizard. And as I mentioned earlier, you can zoom in and you can look at individual times, and then go back and frame again and see the full values. If you want to use these values from that point in another program, you can go in and tell it to view those values, and you see them right here. You can select everything and then hit Control-C or right-click and copy, and then paste it into Excel or whatever other application that you're working with. So that's one easy way to gather those. You can also export this information to a file and then use that. I think one of the options is a CSV file. So either way, it's a little bit easier for me to just grab the values and then cut and paste right into Excel. So anyway, I'm going to move this one out of the way a little bit and then go back over to my display. Actually, I want to do a profile line now for looking at the depth. So I'll create my line. And you see these have arrows on them. If there's a certain value or data set that you're looking at, maybe current velocity or speed coming through here, these arrows denote the arrow or the direction of positive value. So when you see your curve, the positive flow across this line back into this direction will be positive, and directions on this side will be negative. Just that makes it easier to understand what is going to be positive and negative in that line. So let's go in and we will go under take our depth and go to the data calculator, and I'll choose all of my time steps, add that, and then invert the sign and give a new name. Go ahead and compute. Click done, and we see that here. And so now the arc is already here. We have our data set. I can go into the plot wizard, choose observation profile. We have these options for the model intersections, as I mentioned earlier, and the points and vertices. As I said, this particular arc only has 2 points, so the curve for that would not really show up very well. So let's just look at the model intersections, and I will choose those intersections to be shown with the observation profile arc that we have here, and I will choose a specified data set, and in this case I will use the inverted depth, and I'll keep this active time set. So we'll click finish, and it goes out and it shows me. So this one curve that I'm seeing here is across this profile for this particular selected time. If I wanted to look at another specific time, I could do that. It updates the plot. If I look at the initial depth, that's what it looks like. So we can kind of scroll back and forth and see what the change over time is.